So now we move in and discuss the resource. What you see here is a cross-section through the mineralized wireframe. So in other words, in the 43101 technical report that was conducted by SRK, this was published. This shows a cross-section of the mineralization projected from the drill data that we had collected and the report was based on. A maiden inferred mineral resource was produced. And since that publication of that report in 2021, additional reverse circulation drilling, diamond drilling, and assay data has been collected. We want to do an update of our mineral resource estimate with this new data, but we haven't yet initiated that. It's ETEC's intention to update this to include the new data. And as part of this, we've entered into an MOU with Novamera to investigate the use of alternative mining methods that could potentially unlock stranded resources, lower project risk and CapEx, reduce tailings costs and environmental liabilities, and achieve a faster ore production and permitting path. So I'm so happy to have Dustin Angelo here to talk to us about the technology. And I will hand it over to you, Dustin.
All right. Well, thanks, Todd. Thanks everybody for joining us today. Todd, I do appreciate the time to be on this webinar with you. So at Novamera, what we have developed are data-driven hardware and software solutions that enable mining companies to surgically extract ore and leave the excess waste in the ground. So we've developed the enabling technologies. The drilling equipment exists. What we're doing is layering on the enabling technologies to allow mining companies to now take those conventional drills. They're typically large diameter drills that have cutting head sizes of up to 2 or 3 meters in diameter, and now turn those conventional drills into surgical devices. And the way that we've done that is we've created a couple different technologies. One is our guidance tool that is a downhole probe that is the first phase of surgical mining, where we deploy that tool on a standard NQ size core rig. You don't need any modifications to the rig, and it's deployed down the dip of the vein deposit. And just on the right there is kind of a caricature of a vein deposit. So you can imagine deploying the tool every 3 meters as you add core pipe to your drill. And we're taking surveys that go about up to 3 to 4 meters in radius around the borehole to identify those interfaces between the mineralized zone and the wall rock. And what we're doing is, as we move down the dip of the vein, we're collecting all that data and stitching together to create a 3D ore body model for each one of those. And again, that character on the right, you can imagine that each one of those cylinders is that data being collected to be able to ultimately put together this 3D model of the entire deposit and get a very, very high resolution picture of that deposit, more so than you would get with traditional cross-cutting holes, because we're getting data points at basically every 3 meters. So we're getting thousands of % more data points than you would with traditional cross-cutting holes that are maybe on 25-meter centers. So with that additional data is what enables you to get that really high resolution information. So now that you can be surgical, because to be able to go in there and extract an ore body using drills, you need a lot more definition around that ore body than you get with traditional drilling. And so we're also doing this all in real time. So this is part of the production process, and it's the first phase of that. So you can imagine doing that imaging first, and then once you know where to go, right? Now, once you've got that trajectory, because our guidance tool ultimately at the end of the day is building that 3D ore body model, and then it's creating the optimal drilling trajectory to optimize and maximize the amount of ore that's recovered. And those trajectories are what need to be followed by the large diameter drills. But once you know where to go, you still have to stay on course. So we've developed technologies that essentially attach to those large diameter drills. And those drills, just to digress a second, they could be from surface. They could be pile top drill rigs, which use reverse circulation airlift assist to be able to do really low energy, cost effective cuttings transport back to surface. or this can be done from underground using other types of microtunnelers or raised boring machines that you modify basically to flip over and go down versus up. So there's lots of different large diameter tools, and it's our technology that sort of enables them to be surgical. So when you're thinking about that extraction phase, you have to position this drill in the right spot. So we have a position control system. Oh, you want to flip back there you go. There you go. There it is. We have a position control system that collars the hole in the right spot, and it can change for dip and azimuth. And then as you're drilling down and reaming out the material, you want to stay on course. You want to basically follow that cylinder. And with being able to drill on angles, you can drill typically up to between 60-degree dip angle up to 90 degrees. That's kind of not hard and fast rules, but generally speaking, when you're on those angles, you're succumbing to gravity. There's mixed face. So there's a lot of things that are sort of factors that create deviation, and you need to stay on course. And we've created a course correction device that goes in the bottom hole assembly of the drill to stay on course. And then we manage all this and handle all this smart drilling using our control logic, which essentially measured while drilling technology. And so that process is what Novamera's technologies enable. And then part of that process as well is once you've got those open holes, the third stage is to backfill those holes. So as you're going along, you're progressively doing your imaging, and then you're drilling, and then backfilling. And it's all continuous cycle as you move down the strike length of the vein. Right? So you get progressive reclamation. So that's the technologies that we've created, and sort of the process. Because of these technologies, we've created this surgical mining process. Todd, if you want to go to the next slide. So what does that mean for companies like ETAC? Well, they can take these smaller scale deposits, maybe in typical cases there may be stranded deposits, and they're mineral resources, but now they can turn them into mineable reserves. And that's because there's a couple key things from an economic standpoint that happens to enable this to create a valuable project out of it. First and foremost is with surgical mining, you're not creating large open pits, and you're certainly not developing all that underground infrastructure, right? So all that upfront cost that you can think about, that's virtually eliminated. So from an NPV and IRR standpoint, you don't have all of that to overcome in the beginning of your project. This is a scalable solution. So, even junior mining companies can start smaller with 1 or 2 drills and then scale up as necessary. So you don't need to have all your CapEx and all your dollars and money upfront to be able to get going with surgical mining. So you're, without all that development too, you're faster into ore. So again, from an NPV standpoint, you're generating cash pretty quickly. And with the flexibility in the operation, our technologies and the software that we have related to our technologies, we're able to create the mine plans and the sequencing of those of the ore body for extraction. And with that, you can plan better. You got a lot more flexibility compared to an open pit underground, with targeting the higher grade areas first, so that you can maximize your NPV and your IRR. And then, of course, there's some downstream savings as well. The product that's coming out from these large drills, you can basically bypass. You can bypass primary crushing, which is very energy intensive. And then also, as I mentioned before, when you have this backfilling of the holes, you're using the tailings from that from the material that's been processed, right? So then those holes become landform tailings facilities. So your reliance on and your cost for tailings facilities reduces dramatically, and probably most importantly, all the risk around having to maintain tailings facilities. So, there's just not the economic benefits here too. From an environmental standpoint, a social standpoint, it ticks all the boxes. It's smaller footprint mining, so you have a lot less waste. I mentioned the tailings that you can put back into the ground. It's a closed loop system, so from a water perspective, you don't need a lot of water, and you're not discharging water. From a social perspective, this is drilling, so you're not using blasting. And so the local communities won't have to deal with blast schedules. and there's a lot less dust and noise. So a lot of the environmental issues, the social issues, and around getting permitting and social license, this type of technology and this methodology helps to mitigate a lot of that. And again, this all comes back down to time, value, money. If you can get your permits faster, you can get your communities on side faster. It only makes your project that much more valuable. And then, of course, from a safety perspective, huge issue here. As you can see, using drills, you're not at the face. So you're getting, you're reducing your potential for harmful accidents greatly. So, there's a lot of upside in using this technology and surgical mining, and I think that's something that Todd has seen, and we appreciate the opportunity to be working with him, and we're doing that through this MOU that he mentioned. The memorandum of understanding is essentially the codification of the journey that we're going to take together. Right, we're going to be working with Todd and his team over the next several months, doing activities and milestones that take us from today all the way through to implementing surgical mining at his site. And all these milestones that we'll have in place, what they're meant to do is to be able to incrementally understand the value, the applicability, the risk, and how to mitigate risk, and how the operation will integrate. And all these things will be learned over time, and ultimately being able to make this a clear decision to be able to do surgical mining at a much lower risk. And so that process is a number of milestones where we'll be doing things like economic evaluations, desktop studies, to understand sort of what the general economics are of the mine using surgical mining. We'll be in the field calibrating our imaging tool, that guidance tool that does the first stage of surgical mining, of course, going into a bulk sample, and then getting ready for ultimate commercialization. But it's this process that I think it makes it very clear for both us and Todd and his team as to how we're going to go through this and the value creation steps along the way. Todd, you're on mute.
Thanks, Dustin. And now, obviously, this technology can't be applied to every single deposit, and the deposit geometry is going to be critical when the economic evaluation of utilizing this technology is assessed. The one thing that I find very interesting is on the discovery zones, the deposit geometry appears at the first blush to lend itself to a subvertical mining technology such as this. The other advantages, which you've already outlined, Dustin, include things like eliminating fugitive dust. If you have an open pit scenario, that's always an issue. There's no guarantees that this will be the single or primary method of extraction at this deposit, but it is definitely a viable technique or technology to investigate at this stage. And I think by looking at this early, we're going to be able to find where is that sweet spot. And in fact, is this the way that we're going to continue? So we're very happy to be partnered with you. This kind of technology, I think, is the way of the future for the right types of mineral deposits or deposit geometries, as I've said. And quite frankly, we could perhaps envision utilization of this technology increasing our resource base. Dustin, I think this would be one for you.
Okay.
So how will Novamera's approach affect both the potential amount of minerals that can be extracted from the project and the time, speed to commercialization? Maybe you take a crack at it and I'll follow up.
Sure. Yeah, just a couple thoughts there. In terms of the amount of minerals, with this type of technology, the low cost, upfront cost, the relatively lower operating cost too, essentially you can lower your cutoff grades and make certain value rock, more mineable. So I would say, this is probably in comparison to any kind of open pit analysis that's done before. you know, the ability to sort of get at the rock with a lot less waste and a lot less cost will kind of make some of the deposit more mineable. And the depth that the drilling can go at this point, you know, comfortably we say these drills can go about 300 meters. So, you know, if the mineralization is continuing at depth, you can pick up more of it, so you can add more to your overall mineral resource and mineable reserves. In terms of the, I guess how can we strategy time to speed to commercialization? One of the things we didn't talk about with our guidance tool is the fact that, you know, it's used in a surgical mining application, but it could also be used at the exploration level, infill level, where you can supplement your traditional cross-cutting holes with using the guidance tool and drilling down dip and understanding sort of the width of the ore bodies and getting that really high resolution picture of it. You're not going to pick up more grade, but you'll certainly understand the ore body geometry. And we've done our own case study so far on sort of the, you know, comparing an infill study to a traditional infill study to using imaging to be able to infill a certain area of a deposit. And what we've calculated is that you can reduce your time by as much as almost 40%, and the amount of drilling you're doing by about 50%, and the cost reduction is around 40% reduction. So, you know, when you think about you know, what it takes in order to sort of delineate an ore body, if you can cut that kind of time, cost, and meterage out of your programs, you'll get to commercialization faster because you'll delineate the ore body faster, and you'll be moving through that process of development a lot faster.
Yeah, thank you, Dustin. I'm going to try and add a couple other points here. When I look at this technology, you're right, this could potentially open up resources at depth that may not be currently seen as economic because of strip ratios through conventional open pit mining, etc. But also, when I look at it from the approvals process, I see potentially that this type of mining would have less headwinds when you're eliminating things such as tailings ponds, the massive footprint of large open pits, etc. The social acceptance, the social licensability, so to speak, I think could be something that would be advantageous in speeding up that time to commercialization. I also think that the economic modeling, when you look at a financial model for mining development here, people are now casting that further out to closure and beyond. And when you start looking at the full life cycle of a mining development and you start putting these different aspects in, you can't just look at the immediate cost per ton. You have to look at the whole equation. And that's going to influence your economic decision and get yourself to a financial decision point far quicker. So again, I don't want to leave the impression that you know, this is what we're doing right now. I want to emphasize this is something that we are investigating, and it's worth investigating and taking very seriously. I'm bullish. I'm optimistic. I think the deposit geometry, the depth of the ore body that we found to date, could see this technology being, at least at a minimum, part of an overall mining scenario for this project.
And if I may just add on to that, like in terms of sort of evaluating, as Todd said, like, you know, the company's evaluating this technology. Novamera has done a number of economic evaluations of deposits. We've been in the field doing you know, test work. We've done a proof of concept on the entire surgical mining cycle. We've been in the field a number of times with our imaging tool. We've done a demonstration project with Newmont and Vale and Oz Minerals. And so the point of all that is that we're at a stage now where we're very confident in our technology, but more so for especially Todd's purposes early on is we've got a good handle on the economics. What is the cost of these drills? What's the cost, you know, the operating cost, the capital cost? What are the operating metrics? What kind of penetration rates can you get? Things of that nature. Like we've done a lot of work on that, so that the economic model that we'll ultimately put together for Todd and his team, you know, will be grounded in some real information, real data. It's not theoretical. So that will ideally give more confidence to the team that this is a potential option for them to be able to develop the project.
Okay, thank you.